Orion, NASA's next bold step to advance human space exploration, is preparing for its first major demonstration, Exploration Flight Test-1. It's bigger than Apollo, more flexible than the shuttle, but is it ready for deep space? Or does the co-host have other plans? Find out on NASA Edge.
Let's go without him today?
Yeah, let's just do it live.
Okay. Hey, welcome to NASA Edge.
An inside and outside look at all things NASA.
Unfortunately, we are in front of Blair's garage, and I have no idea why we're here.
Yeah, we usually start our shows from one of NASA's field centers or their industry partners, but Blair said he had something special that he wanted to show us today.
Well, while we're waiting for him, today's focus is going to be on the Orion Exploration Flight Test-1, or EFT-1.
Yes, we were most recently at the Kennedy Space Center where we talked to NASA engineers and engineers from Lockheed Martin about this upcoming project.
In fact, in 2014 is the first flight test from Kennedy on board a Delta IV Heavy, and this next generation spacecraft, or the Orion, is going to actually launch into orbit.
Yeah, today we have interviews that will talk about how the EFT was outfitted with instrumentation, parachutes, and the future of Orion manned spaceflight.
It was pretty cool actually being down there at the Kennedy Space Center to actually see this spacecraft, see the panel, the outer panels off, and you actually saw the guts of the spacecraft.
Yeah, it left a lot to your imagination because it's so early in the project.
Hey, let's see if we can get an... Oh, wait a minute, he's coming.
Yeah, maybe get an update of what's going on
Stand by.
All right, guys, it's gonna be... Oh, sorry. Oh, Third Rock Radio, America's space station.
Cool.
You can never have too many notes when you're working.
Now, are you following all NASA safety protocols in there?
Yeah, I'm feeling pretty good about that. Yeah, safety's good. Safety's good.
Okay.
But not only is safety good, I'm telling you, you guys are going to be amazed. You're going to be impressed. This is the best thing I've ever done. It's incredible. 5 minutes.
5 minutes.
All right?
5 minutes.
All right,
Okay,
yep, 5 minutes.
All right, since we have 5 minutes to burn, let's take a look at an interview that Blair did with Jim Bray from Lockheed Martin.
In fact, Jim actually goes over some of the milestones of the Orion spacecraft and how we're inching closer and closer to that 2014 flight test.
And I heard that Blair actually talked to Jim about hitching a ride on EFT-1. What's that all about?
I don't know, let's check it out.
I got to tell you, it's kind of interesting. I'm sitting here looking at this thinking, wow, it's amazing to be here in front of Orion, but this has got to be a real milestone for you and your group.
It's really something, you know, there are 14 different subsystems that all come together. They're all going to pass through this building to make this spacecraft what it needs to be. This is just the first element, which is the primary structure. And yeah, we've got efforts going on all across the country with really smart people. They're carrying a heavy load to make sure that all that stuff gets here. In the next year, it's really going to turn into a spacefaring vehicle.
Well, and that's what I was going to say. So everything now, at least from what I understand, will all take place here. Everything will come here and be installed on Orion.
That's right. So all the subsystems are really being designed and fabricated in other parts of the country. They come here to be installed in this crew module.
I don't know, call me crazy, but it seems like it's perfect for someone like my size, for me to command this kind of module. Do you design it for somebody my height?
Yes, we do.
See, the built-in parameters for me.
Built-in parameters, we can accommodate for anywhere from you to the Jolly Green Giant.
Oh, well, see, now that's what I don't want. I was hoping it would have to be custom-made for me, so you know.
You would be more comfortable in here because, you know, the habitable volume, while it's a lot larger than Apollo was, if you think about the mission duration, it's still a long time to be in there as your primary living quarters.
Well, now, we are still a ways away from human flight in an Orion, correct?
Yeah, we are, but we could be closer. So we're going to pay as you go, and this will be a demonstration of all of our critical systems. In 2017, we've got people that would be pushing for that to be a human-rated mission as well. And we've got people that would actually like to put an astronaut on it. We think it'll be safe at that point in time. But we set our sights out a little bit further than 2017 and are really looking to get that off as our next mission.
Well, now, are you still taking requests for options to add, like, you know, I don't know, coffee makers or certain amenities that might be helpful in space?
We are, you know, but, you know, we have a mass target to meet, and that mass target is really pretty tough for us to do so that we can get all the crew and all the provisions for a very long duration mission. So the crew module that you see here, the next version will have to be lighter and even closer to the mass targets that we need to be able to accommodate all the human systems that we're going to put on.
Actually, when this launches in 2014, you'll still be making improvements and maybe exceeding your requirements by the time we fly in 2017?
I think the best way to say it is that we've been a relatively skinny program, And at this point, we're going to take this spacecraft and we're going to test it to find out just where the margins are.
Okay.
And then we'll be able to take advantage of that in the next iteration to get those margins out, because we want every pound that we can get to be able to accommodate the crew.
So at least you feel good, like you have room in subsequent versions.
We do. It's good to start off a little heavyweight and then you could go on your diet.
Yeah, slim fast
That's right.
for the Orion. Guys, I'm very proud to introduce you to my latest and greatest acquisition. Be careful, there are active tools on the ground, a crew.
Hey, 3-to-1, it's a Lego startup kit.
Ah, probably.
Hey Franklin, that is not Captain America's shield.
Wow.
Can you believe it? No.
Impressive, isn't it?
What's this?
Gentlemen, I want to present to you the centerpiece of CFT-1 Co-Orion,
CFT-1?
co-host flight test.
One?
Well, it's the first.
Wow.
The more important thing is Co-Orion, co-host Orion. I've taken all the technology from Orion and implemented it in my own flight test article.
Where'd you get all this metal?
Yeah.
Let's just say I'm going to need to write into Word from you guys, if that's okay, in the future. Had to scrounge a little bit.
Even worked the parachutes in here?
Parachutes, interesting. Yes, certainly an important part of CFT-1, so I'm sure that there's some space to integrate that.
You know about parachutes.
Yeah, I actually talked to Stu McClung down at the Kennedy Space Center, and he talked to me a little about how they are integrating parachutes into EFT-1, which looks very similar to CFT.
Yeah, CFT, or the Co-Orion, and it does look similar because it's modeled closely on Orion. And I look forward to learning a lot about the parachute technology and integrating it.
Heat shield?
After the true coat.
How has the parachute system evolved since the beginning of the Orion program to where we are today?
When we first started back in 2006 to where we are now, we've had a few iterations. The basic numbers of chutes is the same. The main parachutes have gotten slightly larger. We adjusted them for vehicle mass, but to the outside eye, I don't think you'd notice a change. As we've done all of our development tests, we've done things to improve the reliability and the safety of the deployment. We had a device called a torque limiter. We ran a series of ground tests and realized we didn't need that in the system. We took that out. It made the system more reliable by making it safer. We adjusted the porosity. We added some holes to the chutes to make them a little bit more stable. We used to have where the risers come up to the bottom of the parachute, you'd have a fitting that was called a knuckle. It was a big metal mass. When you throw a big metal mass out of the back of your spacecraft, it can knock around and hit things. We came up with designs called soft links that eliminated that large mass jumping around. And so every time we run a test, based on what we learn, we tweak the design to make it a little bit safer, a little bit stronger.
Well, you have a 20,000-pound capsule, but you don't have it yet. How do you test parachutes to slow something like this down?
So we've built a couple of test capsules that give us the same characteristics. We have what looks like a big giant dart, and we also have a capsule that looks very much like a finished Orion. It's a little bit shorter. You put it on a sled, and you let it go out the back of a C-17.
20,000-pound version.
20,000-pound vehicle,
Okay.
out the back of a C-17 with some parachutes to extract it out, and gravity always works. And once it's out of the C-17, it's separated from the sled that it sits on, starts to fall to the earth, and that starts our parachute sequence. And so we use either the dart or the test vehicle, depending on which type of test we're running, to help prove out that the parachutes are going to behave the way we expect.
Can you kind of walk me through how parachutes will work on Orion when it re-enters the Earth's atmosphere?
All right. You've come through re-entry, you're in the range of 25 to 30,000 feet altitude. Based on computers, parachutes.
I'm going to slow you down real quick. So the Orion capsule is down where like aircraft actually fly before a chute is deployed?
That's correct.
Wow.
Yeah, we've ridden down, you know, I always like to call it, we've surfed down through the atmosphere.
Okay.
Till about 30,000 feet.
Okay.
The first set of chutes are called our forward bay cover parachutes. They are deployed by a mortar, and so the parachutes are packed in a mortar tube, and there's a gunpowder charge in there. The computer says fire. All three of them receive the command, and the three parachutes are shot out of the top of the mortar, and they inflate real quickly. We fire some bolts, and that basically takes the forward bay cover away and gets it away from the vehicle. Immediately after that happens, the 2 drogue parachutes are fired through a mortar, and the drogues are 23 feet in diameter. They slow the vehicle down. They go through their reefing stages, which they open up in stages so they don't overload the chute or the vehicle. And you ride the drogues for a little while until you've slowed the vehicle down to the right point, cut them away, and then the 3 pilot chutes are fired out, and they're actually attached to the 3 large main parachutes, and then they pull the 3 main parachutes out of their bays, and then the 3 chutes go through their reefing sequences, and by about somewhere between 5,000 and 10,000 feet, we're under full reefing and just ride them all the way to the ground.
At the Langley Research Center, we saw some testing of when the Orion model hit the water, it actually flipped over.
That's right. The Apollo history is that happened about half the time. When it's upright, we call that stable 1. If it turns over like you described, that goes to stable 2. So we plan for stable 2 happening. If it happens, there are 5 airbags that are installed in 5 of the 6 gussets in the forward bay. They stay there the whole mission. Once the computers sense we've landed, they actually cut away the main parachutes and then issue a command for the high pressure gas that's been stored to blow down and inflate those 5 bags. And the change in buoyancy just by those 5 bags inflating causes the vehicle to rotate and pop back up to stable 1.
And they're only going to inflate if it's in stable 2?
It'll actually, the way the software is written right now, it'll inflate in either case. And you do it that way if you happen to have an abort and go into the Atlantic Ocean, like into the North Atlantic on a high altitude abort and land in rough seas for some case. Unlikely event, but if you did, you go ahead and inflate the bags because it helps ensure that the vehicle wouldn't, in a bad wave, want to tumble back around.
Gotcha.
I got the parachute,
Okay.
but I'm a little concerned about buoyancy upon re-entry.
Buoyancy?
Orion. Yeah, water landing. It's got to be able to float.
Well, wait a minute. How are you going to get it off the ground?
Launching, I do need a launch vehicle. I mean, I need propulsion, yes.
And what's your destinations? Where do you want to go beyond low Earth orbit?
The best thing to do here is to look at Orion and sort of like follow on their
Space
coattails.
station, asteroid,
Possibly.
Mars.
Speaking of the future, Chris knows a guy.
Yeah, Josh Hopkins from Lockheed Martin. He's sort of the genius behind looking at the flexible path and looking at all the different options that Orion can take. And maybe you can kind of tag along with that approach and see if you can come up with your own destination.
First, I need a flexible path about how I'm going to get this flight test article out of the garage. Like maybe I go through the door, maybe I go through the window, maybe I lift the garage. I've got lots of options that I got to figure out before we move forward.
I don't
Maybe
know.
buoyancy isn't my biggest problem.
One of the missions that we're thinking for Orion is that we may use it in conjunction with another spacecraft, maybe another second Orion, to go to a near-Earth asteroid, and that's something like a 6-month trip. So obviously it's relatively small spacecraft, it's a fairly cramped mission. We're interested in how do we make that mission as short as possible. So one of the things we've been focusing on is how do we find the asteroids that are the easiest to get to, that we can get there, spend as much time as possible, and come back in just a few months.
And how are you able to track those asteroids, years and years down the road?
Yeah, that turns out to be one of the challenges. There are programs in place at various observatories to discover asteroids, particularly the ones that might be hazardous, but there's not a strong program to continue tracking those. And we need to track them over weeks or months or years to really pin down their orbits and also to characterize what they're made of, how fast their spin rates are. And so there's actually a group of volunteer astronomers, essentially. Some of them are at universities, some of them have telescopes in their backyards. And we work with them, they work with each other and with NASA to figure out which ones to prioritize and to try to track those as much as possible.
You're saying that you may have 1, 2, or maybe more spacecrafts.
Right.
So is the idea is to develop a bigger spacecraft for Orion to dock to, they go onto the asteroid, and then Orion will come back by itself?
Right, that's one possibility. One of the things we're trying to figure out is how does an asteroid mission fit into a sequence of initial test flights, and then early sort of steps out into deep space, and then the asteroids, and then eventually leading on to Mars. So depending on the sequence, what you might do is a relatively near-term limited mission with just Orion type spacecraft, or you might use that flight as a way of testing the bigger habitats that you're going to need for a Mars mission. So even though those might be, bigger than we need for a 6-month asteroid mission, we want a way to test fly those and work out the bugs before we commit astronauts to a 2.5-year trip to Mars.
So essentially what we're doing is we're going back to like sort of the days of Gemini and Apollo, where we're doing a series of missions leading up to the actual launch where we're going to have humans actually going to an asteroid and conducting scientific research.
Yeah, I think the analogy to Gemini is a very good one. Back then we identified that we needed to do things like figure out how to do rendezvous and spacewalks before we could do Apollo. And Gemini was the program that basically figured out how to do that sort of thing. We know that we need to be able to keep people safe for something like 6-month trips into deep space or a year into deep space for asteroids. And so one of the things we want to do is start doing deep space trips just beyond the moon to the Earth-Moon L2 point.
Yes, the Lagrange point.
Right.
And what is the Lagrange point?
Well, a Lagrange point is basically a neat little trick with physics to be able to make something like a spacecraft or some other body orbiting in this Lagrange point to be synchronized with the Earth and the Moon, say, or the Sun and the Earth as they go around in their orbits. So there's a L1 Lagrange point that's on the near side of the Moon and an L2 Lagrange point that's beyond the far side of the Moon. If we put a spacecraft at that L2 point, it basically stays over the far side of the Moon as the Moon's going around the Earth. So we have continuous visibility to the interesting science locations on the far side, but we can also see Earth continuously as well.
So the cool thing is that we can actually park a spacecraft in an Earth-Moon L2, leave it there, resupply it maybe every couple of years or so, and then when we send astronauts, all the supplies will be there when they arrive to that spacecraft.
Right, within Lockheed Martin, we've looked at an initial flight that would send just an Orion to there and spend about 2 weeks orbiting and come back. Or you could envision something like a miniature space station there where you could send crews temporarily and they could control robots on the lunar surface.
Is there going to be a point, let's say, of no return where the astronauts are going to be on their own for a while? While they're in space?
One of the big things we have to learn how to do for a Mars mission or an asteroid mission is we have to learn how to get comfortable with the idea that the astronauts can't just come home quickly in an emergency. During the space shuttle and space station programs where we're in low Earth orbit, there's a variety of contingency failure scenarios like that where basically the plan is go home as fast as you can. But when we are something like at L2, we might be, say, 7 to 10 days away from Earth. At an asteroid, you could be 60 or 90, 180 days away from Earth. So you can't just count on being able to get back quickly. You've got to figure out things like how do we prevent those failures from happening in the first place and how do we fix them on board. The other problem is that if we're at an asteroid, it might take something like a minute or 2 or 3 for radio signals from Earth to get to the crew. One of the things we've traditionally done in human spaceflight is the astronauts are really smart, they know a lot about their spacecraft, but there's a lot of things that they rely on for the ground back in Houston to be able to keep an eye on or remind them of procedures, for instance. So we have to figure out ways to bring more of that capability up onto the spacecraft.
And thinking about that spacecraft that's going to be in L2, I guess you're not so worried about time, right? Because if you could send a spacecraft that's very low energy,
that doesn't have the astronauts on board, it can take more time.
It can take more time, whereas once you have the astronauts, you've got to get there and get there as fast as you can. But also try to save as much energy as possible too, right?
Right, so one of the things that's interesting about using Lagrange points is that they might be good places to assemble the spacecraft for deep space missions. So you may be able to use slow, efficient propulsion to kind of climb out of the Earth's gravity well, but you're not going very far. So when it's time to launch the crew, you can get them to that assembly point in a few days, and then you've got your whole system ready to go out to a more distant destination.
Orion is making some great strides. I didn't even realize this whole Lagrange point thing. I'm going to have to hit Wikipedia. I don't even know what that is.
Yeah, make sure you study Earth-Moon L2, Lagrange point.
L2.
And make sure you double check your references before you start quoting stuff.
Yeah, I've gotten burned by that one before. Anyway, I'm feeling a little behind schedule here with Orion.
I wouldn't get discouraged because, NASA didn't start with manned spaceflight a couple of weeks ago. They've been at this for a few years.
Hey, and especially with EFT-1, they've been working on this for a while, and they're on track for the 2014 flight test.
Still, I want to make a big splash. I want to make a big impression.
I tell you what, my advice to you is make sure that Orion is not identical to Orion. Make something that stands out between the two.
Now, you mean something different other than just like adding racing stripes. You mean something substantive.
Absolutely.
Yeah, so for example, why not break the Kessel run in 12 parsecs?
Impressive.
Most impressive.
Well, if you guys think that's impressive, wait till you see my next project. And so what you're telling me is if I sign here, 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 and here, I own the shuttle?
Absolutely.
Good deal. Is this odometer reading correct?
Yes, it is. I confirmed it myself.
Thank you, sir. All right, weather looks good. Let's back it up, remembering all the safety rules. Just important to remember this morning, all the pedestrian laws still apply, even though there are people walking all around the shuttle. We want to be very sensitive. Let's just understand that as we're moving this vehicle, if we want to refer to it as the shuttle orbiter, we are in a free speech zone. Anyway, it doesn't matter because this is now simply a motivator for my work on the next greatest spacecraft from the co-host, the Orion. And what a motivator it is. Thank goodness we don't have to parallel park.